what do I have to have if I'm going to add rational expressions? Must have a common denominator. All right, so if I'm going to get a common denominator, I need to know what these denominators already have in common. How will I find out if they have any factors in common already? By factoring. We're going to factor this one right here. I don't need to factor the other denominator because why? Why don't I need to factor this one? Already factored. It doesn't have an x squared in it, and there's no GCF. No x squared. No GCF. All right, so 2x squared minus 3x minus 5. First thing we always check for when we're factoring is what? Greatest common factor. Do we have a greatest common factor, something that goes into 2 and negative 3 and negative 5 at the same time? No, no GCF here. So that means I move right on to my area model and my x. I put 2x squared up here and negative 5 down here. Remember, the stuff that goes in the area model should be a representation of what I started off with. How do I use this x now? A times c, so what numbers are we multiplying? 2 and negative 5. 2 times negative 5 would give me negative 10. So I need two numbers that multiply to give me negative 10, but add to give me what? Negative 3. What two numbers do you know of that can multiply to 10? 2 and negative 5 multiplies to negative 10. The bigger number is negative, so it's going to add to be a negative. These are my two numbers that I'm looking for. So 2x and negative 5x. And then I want to pull out greatest common factors from every row and every column. 2x squared and 2x. What do they have in common? 2x. Bottom row, negative 5x and negative 5. I can take a negative 5 out. So there's one of the factors of this denominator. Two x minus 5. Then I do my columns. Yes, ma'am? Columns, 2x squared and negative 5x. What do they have in common? Just an x. What about 2x and negative 5? Just a 1. If nothing goes into both of those numbers, it's a 1. Positive because, yep, the 2 right here is a positive. So x plus 1 is my other factor down here. So I'm going to rewrite my two fractions. I have x plus 1 in this numerator. In factored form, 2x minus 5 and x plus 1. And I want to add that to this fraction. X plus 1, 2x minus 5. Do my denominators have anything in common? Any factors in common? 2x minus 5. They have those that are the same. The first denominator has a factor that the second denominator doesn't have. how can I give this factor to this denominator so that they have the exact same denominators? Yep, multiply x plus 1 and x plus 1 on both sides. I need parentheses around this because I'm going to be multiplying these pieces together. Yes, ma'am? We're multiplying because I need the denominators to be the same. And in the first fraction, there's not anybody here. In this fraction right here, these two factors are being multiplied. By definition, that's what we find when we factor, is two things being multiplied together. So I need it to be exactly the same on the other fraction, so I'm going to have to multiply, and I have to do it to the top and to the bottom. All right. So my first fraction doesn't change at all. I have x plus 1 over 2x minus 5 times x plus 1 plus, now this side we're going to have some changes. My denominator, 2x minus 5 and x plus 1, I'm going to leave that in its factored form. In the numerator, I'm going to have to distribute that because I need to combine it. I need to add it with this numerator over here. I have to use double distribution because I have two terms here and two terms here. So this x has to get distributed to both of those pieces. X times x gives me what? X squared. And x times 1? 1x. And then I have to distribute the 1 to both of these pieces. What is 1 times x? 1x. And 1 times 1? 1. Are my two denominators the same? Yes. This matches this. So I am going to add these numerators together. Two x minus 5 and x plus 1 in my denominator. If this had been a minus here, I would have to distribute the minus to every piece that comes after it. But because it's a plus, I don't have to do that. Are there any like terms up here that I'm going to be combining together? Yep. This x right here, this x right here, and this x right here. How many x's do I have altogether there? 3. I'm going to put my x squared at the front, and then it is plus 3x. Do I have any other like terms? 1. Positive 1 combined with another positive 1 gives me what? Plus 2. So I have added these two rational expressions together. Is this fully simplified? Let's see if we can factor that numerator. Does the numerator have a greatest common factor? Nope. X squared plus 3x plus 2 has no GCF. Well, we're going to find out. So I'm going to draw my area model and my x. X squared goes here, 2 goes here. What do I put up on top of the x? A times c. So what numbers am I multiplying together? X squared and 2. So I have a 1x squared and a 2. So I need numbers that multiply together to give me 2, but add to give me what? What multiplies to 2 but adds to 3? 2 and 1. This does factor. So 2x and 1x X squared and 2x, what do they have in common? X squared and 2x. They have an x in common. What about 1x and 2? Positive 1. So x plus 1 is a factor of this numerator. Now we're going to do the columns. X squared and 1x. What do they have in common? X. 2x and 2? Positive 2. X plus 2 is the other factor of the numerator. Write out my common denominator here, 2x minus 5, x plus 1. Can this reduce? We can cancel out the x plus 1s. Yes, Julia?
Does it matter the way you arrange?
This?
No, like the ending.
Ending. These pieces?
The end where you put the x and plus 1 and x plus 2.
If you have a 1 here, if you have a 1x here, it has to be a 1 here.
No, I'm talking about the end.
Oh, what I'm doing over here? No, you can put whichever factor first. Does not matter. I'm sorry, I misunderstood your question. So added together and then fully simplified. There's my final answer. All right. We've got the rest of the class period where I am more than happy to answer any questions you guys have off of the review. There were 9 questions on the review. Yes, sir. Calculator, absolutely. Which questions off the review do you guys want to see me work through? Number 3? We can start with number 3. What's going on between these two fractions? Division. What do we do when we're dividing fractions? Yeah. Does anybody else not have a copy of the review? No, I passed it out on Friday. If you can't find it in your bag, I'm happy to give you another copy. You're welcome. You're welcome. What do we do when we divide fractions? There's 3 words that always pop into my head when I see division. Keep, change, flip. So we're going to keep this one. We're going to change this to what? Multiplication. And then we're going to flip this fraction. So when I do my keep, change, flip, I would have 9x squared yz over 4z to the 4th times, because that changes, and then I flip this one. So 50x y to the 4th z squared over 12 x to the 4th y squared. Yes, sir. Oh, thank you. I think I was looking at the exponent and I wrote the wrong thing down. Thank you so much for catching that. All right. Keep, change, flip. How do I multiply fractions together? Straight across. So when I multiply straight across, I'm going to put the numbers up at the front. So I have 9 times 50. I'll simplify it in a minute. I just want to write it out as a single fraction here. Times x squared times x. I'm going to group the letters that are the same together. Times y to the 4th times z squared over, and I'm going to do the same thing down here. I'm going to put the numbers up at the front, and I'm going to group any of the letters that are the same together. So 5 times 12 times x to the 4th times y squared times z to the 4th. Let's look at the variables first. Let's look right here. I have x squared times x over x to the 4th. What does x squared mean? So I have x times another x, right? That's what I have in the green box in that numerator, x squared times x. What does x to the 4th mean? X 4 times.
Is that a 2 or a 3 on this one?
Where?
In the green box.
Right here?
Yeah.
That's a 2. It came from this one right here. I know it's kind of hard to see.
Why is it 3 there?
2 right here, and another one right there. Yep. Good questions. This one right here is right there. All right. Is there anything the same between the top and the bottom? I can cancel out 3 of these because they're the same between the top and the bottom. Which means I have how many x's left? 1. On the top or on the bottom? On the bottom, so I'm going to put it on the bottom here. I'm going to do the exact same thing with these y's. How many y's total are there up on the top that are being multiplied together? 5. I have the 1 right here. And then I have 4 from y to the 4th. 1, 2, 3, 4. How many y's are being multiplied together on the bottom? 2. What can I do? I can cancel out 2 of them, which leaves me how many y's? 3 on the top or the bottom? On the top. If I have 3 y's being multiplied together, that would be y to the 3rd. So I have y to the 3rd that's up on top. All right, let's do that now with our z's. How many z's are being multiplied together on the top? 3. 1 that comes from this z all by itself, and 2 that come from the z squared. How many z's in the denominator? 4. 1, 2, 3, 4. What can I cancel? I can cancel 3 of them, which leaves me how many? On the top or on the bottom? On the bottom. All right, so I'm going to pause here for just a second, and I'm going to bring my numbers over. Up on the top, I had 9 times 50. On the bottom, I had 5 times 12. Can I write any of these as their factors so I can see if there's anything in common with factors on the bottom? 9 is 3 times 3, so I could write this as 3 times 3. Will that cancel with anything that's on the bottom right now? No. Can I rewrite 50 in any way? That's 10 times 5. Will that cancel with anything that's on the bottom? Cancel with the 5. So this 5 is gone because it cancels with this one right here. Can I rewrite 12 in any way that's going to help me cancel? 3 times 4. And that's going to allow me to do what? Cancel out one of the 3's. Okay, before it gets too confusing here, the pieces that I have left, I have a 3 and a 10 left up here. So 3 times 10 times y cubed over, what do I have left on the bottom? 4xz. Does anything in the numerator have a common factor with anything in the denominator? Is there anything else that I could write it out in its factored form? Yep, 10 is 5 times 2, and I heard 4. 4 is what? 2 times 2. And that means I can do what now? I can cancel out one of the 2's. Will anything else cancel at all? No. Can I factor anything more? No. 3 is just 1 and 3. There's no other way to get it by multiplying. 5 is just 1 and 5. 2 is just 1 and 2. So now I'm going to multiply together what I've got left. What is 3 times 5? 15y cubed in my numerator. What do I have left in the denominator? 2xz. Do you have to use as many steps as I used? Could you use more? If you really wanted to. Could you do it in less steps? Yeah. I did it in the steps that I did so that we could see everything that was happening. And as soon as it started to get to be too much going on, then I wrote something down again. I wrote down what I had, so I stopped getting confused with all those pieces. Yes, sir?
Are you going puzzle piece tomorrow?
Yep.
You have a quiz tomorrow?
Yep. Yes, ma'am.
Well, what are these problems division?
Very likely. So in this module so far, what we have studied is simplifying. That's where you factor and cancel. Multiplying and dividing, adding and subtracting. You can probably expect at least one of each of those types of questions. So questions 1 and 2 on the review are simplifying questions. Adding and subtracting are problems 5, 6, and 7. 5, 6, and 7 to practice adding and subtracting. And then multiplying and dividing would be 3, 4, 8, and 9. Yes, ma'am.
For number 4, do we do keep change?
No. So number 4 is like this right here, after we did keep, change, flip. So that's where we're starting. That's the step that we're starting this one at. So if there's division, we do keep, change, flip, and then we do it just like a multiplication problem from there. So this, I would do exactly like I did number 3 after I did the keep, change, flip. Does that help? Okay. What else do you guys want to see?
7.
Number 7.
Oh, wait, no, 9.
Number 9. Very last one. Ooh, I don't blame you. What kind of a problem is it? Division, which means I need to keep, change, flip. So keep the first one, change the second one, or sorry, not change the second one, change the operation, and flip our second fraction. All right, so I'm going to do just that part. 2x squared plus 3x plus 1 over 2x squared plus 4x minus 30. Change this to multiplication and flip this fraction. 2x squared minus 7x plus 3. On the bottom in parentheses, 4x plus 20. And in another set of parentheses, x plus 1. I need to know whether there are any common factors, because when I multiply this straight across, I'm going to look for any factors that are the same between the top and the bottom, because they'll cancel out for me. I can't cancel the 2x squareds here because that's not a factor. Those aren't pieces that are being multiplied. Those are pieces that are being added. And I cannot cancel out things that are being added. What do I have to do to see if there's any common factors? I have to factor everything I possibly can here. So we're going to factor the numerator of this first fraction. Does it have a GCF? No GCF here. So I need to do my area model and my x for the numerator. 2x squared here, 1 here. What would go up on top of my x? 2 times 1, right? Or 2x squared times 1. So I need two numbers that multiply to give me 2, but add to give me what? 3. What multiplies to 2 and adds to 3? 2 and 1. So 2x and 1x. Let's do our rows first. 2x squared and 1x. What do they have in common? Just an x. What about 2x and 1? What do they have in common? Just a 1. So x plus 1 is one of the factors of that numerator. And then I'm going to do my columns. 2x squared and 2x. What do they have in common? 2x. One x and 1. 1. So 2x plus 1 is my other factor here. I'm going to need to factor the denominator here. Scoot this down just a little bit. Is there a GCF here? GCF of 2. So I put my GCF down right here. And then I'm going to divide every single piece there by 2. 2x squared plus 4x minus 30. Divide each piece by 2. There's my GCF out in front. X squared plus what? 2x minus 15. Now my area model and my x. X squared goes here. Negative 15 goes here. What goes up on top of my x? Negative 15, because I have 1 times negative 15, so negative 15 up here. What goes on the bottom? 2. What multiplies to negative 15 but adds to a positive 2? Negative 3 and positive 5. So negative 3x, positive 5x. GCFs out of my rows and columns. X squared and negative 3x, what do they have in common? X. 5x and negative 15. Positive 5. So x plus 5 is a factor there. That's going to go next to the 2 that's at the bottom. X squared and 5x. X. Negative 3x and negative 15. Negative 3. So x minus 3. Times, and now I come over here. I have to factor this numerator. Yes, ma'am. You will have time to factor everything that needs to be factored, yes. First thing I always look for when I'm factoring, GCF. Is there anything that goes into 2 and negative 7 and 3? No GCF. All right, so I'm going to draw my area model and my x. 2x squared goes here. 3 goes here. What goes up on top of my x? 6. 2 times 3. So multiplies to give me 6, but adds to what? What multiplies to negative 6, but adds to negative 7? Negative 1 and negative 6. Negative 1x, negative 6x. 2x squared and negative 1x, what do we have in common? We have x in common, right here. What about negative 6x and 3? 3. 6 doesn't go into both of those, but 3 does, and it has to be a negative because it's touching a negative box right there. So x minus 3 is a factor for that numerator. What about 2x squared and negative 6x? 2x, negative 1x and 3? Minus 1 or negative 1. So 2x minus 1. The denominator looks factored already, right? What do I always have to check for to see if something is factored? GCF. Do either one of these have a GCF? This has a GCF of what? 4. So I've got a 4 out at the front. What would I have left over if I take a 4 out of each of these, if I divide them both by 4? X plus 5. Is there a GCF over here with this x plus 1? Nope. All right, when I multiply fractions together, it's straight across. So everything in both of these numerators is getting multiplied together. X plus 1, 2x plus 1, x minus 3, and 2x minus 1, all up in the numerator. Down in the denominator, I've got stuff inside parentheses, but then I also have this 2 and this 4 that are being multiplied together. What is 2 times 4? So I have 8, and then all of those parentheses. X plus 5, x minus 3, x plus 5, and x plus 1. Are there any common factors, anything inside parentheses that will cancel out with an identical set of parentheses on the bottom? I heard x minus 3. Anything else? X plus 1 will also cancel. Is there anything else that is identical between the top and the bottom? Two x plus 1, does it have a match down here? Because the only way it can cancel is if one is on top and one is on bottom.
Is the last one a negative one or plus one?
That's a minus 1 there. It came from this right here. All right. If nothing else can cancel, I'm going to write down the factors that I've got left. 2x plus 1. 2x minus 1 were left in my numerator. What all was left in the denominator? The 8, and then 2x plus 5. So I could write it as x plus 5 and another x plus 5. Or how else could you write that? To the second power. So you could have 2x plus 1 times 2x minus 1 over 8 times x plus 5 squared. You could also have that. Means the exact same thing. Yep, that's the final answer. We've got about 4 minutes left. Is there anything else that you guys would like to look at?
Can you go over the first Bellwork?
Go over the first Bellwork. No, that was your work yesterday.
I was here.
I didn't go over it in class.
Oh.
So you need to simplify that one on your own and then turn that in.
We're telling you to listen to me.
Yes, your Bellwork, if you don't have it done because you were absent yesterday, you can turn it in tomorrow. If you are done with it because you were here both days, turn it in on the review side. The answer key for the entire review. We went over some of the harder problems here, especially this last one, because this was a ton of factoring. On the test, I will not have you factoring 4 different pieces for one problem. You might have to factor 2 pieces, like on a simplify problem, but you're not going to have to factor 4 different pieces for a single problem there. To get to my answer key, if my board decides to work, here we go. So you have to go to modules. When you go to modules, scroll all the way down until you see Tuesday, March 21st. The answer key is not right here. You have to actually click on the review, where it says review for module 9 quest. Click on that piece right there. And then scroll all the way to the bottom of the page. There is my answer key. Does everybody know how to find that now? Go to modules, find today's date, click on where it says review for module 9 test, and scroll to the bottom of the page.